In this module, we cover the CONN objects. Experienced Automic users should be familiar with connection objects to create connections to various systems for functional purposes, like running certain types of application jobs. With Kubernetes, each connection object represents a connection to a cluster. It requires an IP address or DNS. Working together, the connection and the agents allow the submission of jobs in the appropriate namespace. When the agent first connects to the engine, two templates are created. One, the K8s CONN, is for the cluster or source code manager hosts. The other is only needed for SCM authentication purposes. We'll be able to create as many CONN objects as there are instances. Then we reference the connection in the K8s jobs at design time. In both cases, Automic needs to authenticate before it can submit processes. In the case of a K8s or scaling job, authentication details are stored directly in the CONN. As we've already explained, in the case of the SCM, authentication is stored in a separate CONN. Finally, we'll perform a demo and show how to set up the two CONN objects. For every cluster instance, you need a matching CONN object. You use the new template visible in AWI when the agent first connected to the engine. When this is done, the jobs we create are submitted to the appropriate instance by referencing the CONN in the namespace. We have multiple types of processes and job types, but they all use the CONN object to connect to the cluster. We'll come back to this. The agent simply handles the relationship with the automation engine. In the K8s connection object, we have a single drop-down menu for the authentication type. Authentication is done with Kubernetes service account tokens. You can either enter the token directly or source it from a file with a path and name. In the case of a job executed from a secure source code management system where files are protected, you reference the SCM cluster URL in the CONN objects and authentication for that cluster. In the SCM connection, you enter the login information to the SCM system itself. You can either use the basic ID and password system or use an authorization scheme like Bear. In the case of public SCMs with unprotected files, the SCM connection field can be blank. In order to submit processes into a Kubernetes cluster, you have to authenticate with one of the system accounts, meaning no ID or passwords. Instead, we authenticate with a system account token, which you should know how to generate with native Kubernetes tools. So the K8s CONN objects have two authentication types: the token, which you can enter directly in the field on the form, or token from file. You output the token to the file and reference it here. We expect students to be familiar with service account tokens. They're generated separately using the kubectl command in the CLI configured for that particular cluster. You generate a token and copy the resulting block of text here. You may be faced with a specific issue. Service account token procedures are often configured with a 60-minute expiration, which is a problem for us, obviously. We cannot possibly update them every hour. For this reason, we recommend reading up on important material regarding secret management for service accounts. Tokens can be mounted into pods using projected volumes. Simply create a secret to store the token. Kubernetes will then use the secret to create token files and mountable paths. You then reference the name of the volume and the mount path in the form, and you should be set for good. You may want to run processes from source control, say GitHub or SVN. In this case, you would create two CONNs for the jobs objects. First, a K8s CONN, in which you reference the URL of the SCM. Second, an SCM-specific connection for authentication, since it's done a little bit differently. You rely on two types, either basic with a user and password, or the authorization scheme, which is Bear. If you're not familiar with this, we recommend reading up on materials found in the Kubernetes documentation. Bear is an HTTP authentication scheme with specific tokens called Bear tokens. They're encrypted blocks of characters stored in the response of a request for login. Let's proceed with a demo of the CONN objects. We've created a folder dedicated to Kubernetes. We already have a couple of connections in there. Let's create a new one. Under the K8s category, we see our two templates, the regular K8s connection and source code management. Let's start with K8s. You indicate the IP or DNS name of the cluster. We're going to enter one of Broadcom's test environments, which we conceal. We've already generated a service account token for the purposes of authentication, and it's been stored on the agent system. We reference it here. Ideally, you should be using a projected volume and mounted path. If you want to check that your connection is valid and you already have a job defined for that cluster, you can simply add the new con and click Browse to see if you can access the list of namespaces on that cluster. If not, you'll have to create the initial job, which will cover another module. You also have the option of running processes from a source code management platform like GitHub. The method is the same. You create a K8s connection and reference the SCM's URL. The only difference lies in the login mechanism for the SCM, which cannot be stored in the base con object and requires a different type of con called SCM. It only stores authentication details. So the K8s CONN stores the service account token to the Kubernetes cluster. This connection stores specific authentication details to the SCM. We have two authentication types: basic, which stores ID and password to the SCM, or authorization scheme, which relies on bearer tokens. We have an SCM job, although we'll take you through the process of creating one in another module. Let's see where this connection object goes. In the job itself, you have two connection objects, one for the SCM Kubernetes cluster and one for the system itself.